Alright, the next lesson is over the unit circle, which is a big part of trigonometry, and in physics we use it to get the direction of objects. And when we talk about direction in physics, we're usually talking about an angle in reference to this unit circle. Alright, so let's just move through it. First of all, the unit circle has a radius of 1. So any which way that you move, you are moving 1 unit over. So there's the 1 on each side. Alright, the next thing that we'll talk about is how the unit circle relates to the trigonometric functions. The x movement is always the cosine value, and the y movement is always the sine value. Okay? What I mean by that is, on the unit circle, if you move in this direction, you're getting the cosine value. The cosine of this angle here is going to be 1. Now this angle is 0 degrees. Or if you've already made it one full rotation around the unit circle, it's 360 degrees. And actually it can be any multiple of that. If you moved around the circle, 5 times, then you would have 5 times 360, and your cosine value is still going to be 1. Alright? What you see here in blue are if you were measuring in radians. Radians, if you're not familiar with it, is just another angle measurement, except it uses pi instead of degrees. So this would be 0 pi radians, or if you've moved around the circle, it's 2 pi radians. So anyways, those are just a couple of ways to measure things. We're going to always talk about the degrees in this class, and there will be one section over circular motion when we'll switch to radians, and then after that we'll switch back. Alright, so I'm going to focus on the degrees. Right here is 0 degrees. Then you can move up to 90 degrees, and we should know that from our right triangles or a square or anything like that. We have a right angle here, so that's 90 degrees. To get from here to here, you had to travel through 90 degrees. Alright, if you moved all the way around here, now you've traveled 180 degrees. Notice there's another 90 degree angle here, so you've traveled through two 90 degree angles. From 180 you move down to 270, and then on to 360. Okay, so in your calculators, I want you to get your calculators out and put it in degree mode. And then let's say that you took the cosine of 90 degrees. Alright, if you moved up to 90 degrees, we want to know what cosine is. Remember, cosine is always the x value. Alright, so look at your ordered pair here. The x value is 0 and the y value is 1. So in your calculator, when you take the cosine of 90 degrees, the calculator should tell you 0. If you take the sine of 90 degrees, your calculator should tell you 1. And you can verify that that's true. Over here, if you took the cosine of 0 degrees, your calculator should give you the value of 1. And if you took the sine of 0 degrees, your calculator should give you the value of 0. Now remember, you are in this first quadrant, so all values are positive in this quadrant. You're moving in a positive x direction, and you're moving in a positive y direction. Okay? If you're in the second quadrant, your x values will be negative, as you see here, but your y values are still positive. If you're in the third quadrant, your x values are negative and your y values are negative. And if you're in the fourth quadrant, your x values are positive and your y values are negative. Okay? So just remember that for your ordered pairs, like you've got a -1 here for your x value, but you've got a -1 here for your y value. I also overlaid your Cartesian coordinate system here, your north, south, east, and west. Alright, and I remember that by traveling clockwise, you have never eat sour watermelons. I know it's weird, but that literally runs through my head every time I'm putting that on the coordinate system. Okay, so now let's go ahead and talk about how we can get a direction out of this. Alright, so let's say that I overlaid this line here on the unit circle, and I told you that it is 45 degrees up to this line from 180 degrees. How could you figure out how many degrees it is from 0? Alright, so if moving in this direction increases the angle from 180 to 270, and moving in this direction decreases the angle from 180 to 90, then we know that we get smaller angles in this direction. Alright, so we could take 180 and subtract 45 degrees from it, and that would tell us what the angle is from this direction around to our line. And when we do that, we get 135 degrees. I'll go ahead and write that in. Okay, now both of these angles here are valid ways to describe where that line is. Okay, we could say that this line is located 45 degrees away from 180, or we could say it's located 135 degrees away from 0, or if each one of these quadrants is equal to 90 degrees and this section here is 45, then that means that this section here is 45 also. So we could put that in if we wanted to, which gives us another way to describe this position of the line. We could say it's 45 degrees past 90. Alright, we could also incorporate our Cartesian coordinate system, which is what we do in physics. So you could say that this line is located 45 degrees west of north. Alright, now what that is here's west, here's north, 45 degrees in the westerly direction from north. Alright, so that's talking about this movement right here. So 45 degrees west of north, or you could say, we could describe this angle, we could say it's located 45 degrees north of west because we're moving towards the north from the west. Alright, or again, you could say it's 135 degrees from 0. That's actually how I prefer to do it in my class, is to always use 0 as your reference. There will be times when we'll use the north of west or south of west or something like that, but I do prefer personally using 0 as a reference point. Alright, so let's see if you can do one. Let's go ahead and put in maybe a line right here, and I will tell you that this is 30 degrees. Okay, so I want you to tell me the location of this line using 0 as a reference point, and then using your Cartesian coordinate system. So if you need time to do that, pause the video and figure it out, write that down first, and then come back for the answer in just a second. Alright, so if you were to travel from 0 degrees over to this line, first off, traveling from 0 degrees to the gray line here gets you to 270. And then if you go 30 degrees past 270, that gets you 300. So that's where we're getting that number from. It's just 270 plus this little extra piece, 30 degrees. So in reference from 0 to this line is 300 degrees. Alright, now they originally gave us 30 degrees, and they said it was 30 degrees from the 270. Alright, 270 corresponds to south, and it told us with that arrow right there that we're moving towards the east. Alright, so we could say that this is 30 degrees east of south. Alright, so either description is appropriate. We can say that the line is located 300 degrees from 0, or that it's located 30 degrees east of south. And that's how we will continue to do directions anytime that we describe where something is in physics. Alright, the final thing that I want to talk about is the maximum values of the sine and cosine function. Okay? And this comes up a couple of times throughout the course, and when I talk to you about it, I want you to be able to tell me the answers. So I'm going to go ahead and preface it now. Alright, cosine, like we said earlier, always refers to the x value on the unit circle. So in your ordered pair list, cosine is always the x value. These are the maximum values for that degree. Alright, so the maximum value at 0 degrees in the x direction is 1. Okay, up at 90 degrees, the maximum value for the sine of 90 degrees is 1. So the sine function, and this for the sine function, the cosine function, these are the maximum values. No matter what angle you plug in, okay, it could be anywhere between 0 and 90. The maximum value that you can get for the sine function is 1. Anything that you plug in here, like 45 degrees, it's going to be less than 1 because it's not on this line yet. Okay, the cosine function, the maximum value that you can get for the cosine function is 1. Any angle that you get in between here and here brings your x value less than 1. Remember, here's the radius of 1 out here. If I plotted a point right here and we came down on the x value, it's going to be something that is less than 1. So the maximum value that the cosine function can get is 1. And I wanted to show you the graph of the sine curve. So if you were to graph the different angles in your graphing calculator and take the sine of them, then this is the graph that you would get. So, and this follows the unit circle. Alright, it's 0 degrees, and then if you go back and look at our unit circle, this one measures it in radians. So then you get pi halves, pi, 3 pi halves, and 2 pi. That's one full rotation around the unit circle. Okay, so I just overlaid the angles there so that you can see how it's traveling around the unit circle. But what I'm interested in is the graph here. These are the values that you would get if you plugged in the sine of these angles. If you plug in the sine of 90 degrees, then you're going to get 1. So look, right over 90 degrees, the value is 1. And look at this graph. That's the highest you can get. You can't get a value over 1. Alright? In either direction. You can't go beyond 1. So the maximum value of a sine graph is 1. Okay? And then you can get the values of the angles in between. If you took the sine of 0, you get 0. That's where it intersects right there. If you took the sine of 270 degrees, you should get -1. If you take the sine of 180 degrees, you get 0. Alright? Because that's where it intersects, right on the 0 line. So that's your sine graph. Let's take a look at the cosine graph. Alright, so here is the graph of cosine. Alright, so looking at this, the maximum value that you can get for cosine is 1 also in either direction. We've got +1 and -1. and then you'll notice how it's traveling around the unit circle. We'll start at 0 degrees, and then you go to 90, and then 180, 270, and 360. Notice that the cosine graph starts at 1, so if you plug in the cosine of 0, your calculator should give you 1. If you plug in the cosine of 90, then your calculator should give you 0. You're on the 0 line over here. If you plug in the cosine of 180 degrees, then your calculator should give you -1, and so on and so forth. So this graph here shows you what your maximum values in the cosine function are, and those maximum values are 1 in either direction. You've still got your +1 and your -1. So anyways, that's important. Please be aware of that. I think that's all for today. Thank you for learning with me, and I will see you next time.